at this example, and that's going to be in your note. Fruit produced in relation to growing conditions. We need to find out if there is a relationship between fruit produced, and that is in grams, and growing conditions. Like what? How much water we are added in milliliters, how much light received in minutes, and how much fertilizer in microliter. So, is there a relation between water addition, light received, and fertilizer? Well, there is a spelling here. Right, light received. Okay. Fertilizer and microliter and fruit produce. So how are you going to do this relationship and find the equation to determine if there is a relationship? First of all, we have to go to data. I know you see the answers, but I'm going to do the same thing again. Data analysis, and you go to regression. When you do regression, the input Y range is whatever is fruit produced in grams. So what is the output is the fruit produced. So I'm going to put this with the title all the way down. This is the fruit produced. And now, what is the input X? So I'm going to use these water, light, and fertilizer all the way down. And this is for the input X range. The input Y range, we just put it. We're going to use the labels because we put the labels at top. We're going to use the confidence level, 95%, as we usually do. We're going to choose the output range. Let's choose another output range, not the one you have here. I'm going to select it here. And then I'm going to select residuals, standardized residual if you want to, or you could just leave it as this. You don't need plots, you don't need line fit plots or normal probability plots. So we'll say OK, and then we can find the results. So this is the regression, multiple regression, 0.797, which is the same answer that we have here, 0.797 and 0.6336 for R square, adjusted R square, standard error 0.36, and observation is 11. Now, we could see that the significance here is 0.057, which is not great, but let's see, very close to 0.05. But the equation that we're going to be using to predict the fruit produced in the future is this equation. This is the equation that we're going to be using to predict the future. Okay, of course, you have the lower 95%, upper 95% to find the statistics of this type of analysis. Okay. So you will go see, and this one, it's the same thing. So we're going to have the coefficient. This is for the intercept. This is for the factor for the water in milliliters. And this is the factor for light in minutes. And this is the factor or the coefficient for fertilizer in microliter. So you put the equation. Y. This is Y is in grams of fruit produced. Y equal to 1.54, this is the intercept, plus 0.0006, and that's where you have it here, 0.0006 times the water in milliliters, plus 0.0002 or 0.0026, which is 0.0003 times light received in minutes, and plus 0.002 times fertilizer in microliter. So this is the equation that we're going to be using later on to predict what will be the grams of fruit produced. Let's say, for example, if I give you a number that you want you to put into the equation to find out how much fruit produced. Let's say that we did this test 5 years back, and now we have how much water. Let's say water in milliliter. Let's say it's 100 ml. Light received. In minute. So let's make this one should be a bigger. In minute, let's say 45 minutes. Light received is very close to each other, so I'm gonna choose light received. Okay, and then the last one, fertilizer. Fertilizer in a microliter. So I'm gonna say insert. So you're gonna do microliter. So this is micro and close liter, and that is in, let's say in microliters, 12 microliters. And now we could plug in the numbers. We should multiply 100 times 0.0006 plus 45 times 0.0003 plus 12 times 0.002 plus 1.54, and that will give you how many grams of fruit produced. Okay, hopefully this concept is easily understood, and we will see you in the next concept. So thank you very much.